Good evening, guys. And today we will be learning a lot of few small topics today. So today is Kubernetes day 15, right? It is day 15. So, guys, as I said, if you're feeling somewhere the audio or video is stuck, actually, just interrupt me at the same instance so that I will repeat it actually. Because in the previous sessions, I see that many of the places, right, the video got stuck actually, so you're not able to see what I'm doing. So again, I would request you all that you just stop me so that I will repeat it again. Okay. So today, what we are going to cover actually. See, we have a lot of small topics. You have already mentioned here. The same thing I would mention over here also. That we have to cover the demon set. These are very small topics, sir. It will take hardly, I think, 10, 15 minutes to take. Then at least I am planning to cover these things today actually. Okay. So instead of covering volumes and config maps and secrets, right? These are big topics. This will take time actually. Okay. But rather than that, I thought I will just finish off some smaller topics today, so that we are free of from all small topics. So daemon set is there, and then like we will be understanding about the scheduling topology.
And Rajesh bhai, just to remind, that blue-green deployment, canary deployment, lab we didn't do.
Yeah, we will do it, sir. Actually, we'll do that.
Okay, okay.
We have kept that
And
pending.
one more thing, Rajesh, I
Mm.
thought of actually updating you something on that. I went through
Mhm.
that video again, that
Mm.
session again. See, that
Mm.
was like, Canary is a different deployment strategy, and blue green is
Mm.
a different strategy.
Mm. Mm. Okay.
Canary would be like a percentage based deployment actually.
Mm.
In that you'll utilize minimum resources to actually deploy. But in
Mm.
blue green, it would be like, you need a set of a whole
Mm.
set of resources which will be
Mm.
on hold until the deployment is complete on blue, and then you
Mm.
will actually switch the traffic to the green,
Correct. Correct.
right? So this is
Mm-hmm.
too different and that is different. And this one, when will you use blue green? When you would use this, say for example, you have some applications which have the downstream or some kind of dependencies, right? In that sense, in that case,
Mm-hmm.
you would go
Mm-hmm.
for blue green dependencies. It
Mm.
means like some critical applications will have that.
Mm-hmm.
And canary, you will have like, it is also some kind of that
Mm.
deployment is also used for some critical applications only. But here
Mm.
in this case, what actually happens is
Mm.
you can test the application in both the production with the new version and the older version, compare
Mm.
it, then go for the next step. Like that it can happen in canary.
Okay.
But for us, that this session, it went actually in a different way, so just wanted to update you on this, Rajesh.
I think whatever you said, no, same thing I told. See what has happened, right? Career deployment, I told that actually that we will have two sets of deployments, right? In one deployment, what happened, right? You might be having some, like set of, pods running that. So suppose at the time you need to, upgrade from the existing version to the higher version, right? So what you will do, you will try to do all those migrations, everything means you are going to do the changes in the next set of the deployment, right?
Hmm.
Correct. So what happened, right? So that what is happening is that actually the whatever the whatever the request comes in, right? The request shouldn't be disturbed. So that there will not be any kind of a downtime. That's what we discussed, and it can be divided across the percentage also the flow. Like here, what happened, right? Even though you're doing a deployment, assume that actually in the other set actually we have started doing the migration. It means that we have started doing the update of the higher version. Suppose some pods came up actually in the newer set actually. You can you in the kernel deployment you can say that okay just no you can redirect okay that in the main traffic in the main set, right? You can send the 90% of the traffic, and in case of a newer set where it is upcoming, right, only few parts have come up, but still you say that okay I can even send 10% of the traffic, that you can do it, right? Same thing in the Canada deployment also you can do that. So what I have read that what I went through that actually both are same. Canary
Mhm.
deployment or red green deployment are same.
The both
Blue green,
cannot
sorry.
be same, Rajesh. They both are actually different.
Okay, and then I'll get back to it because
I have shared a document also on that because I worked on those strategies before.
Mm-hmm.
So
Okay,
so I
then
was
we will see them.
just
Then we
go
will
through
see.
that, Rajesh. I mean, I may be
Yeah.
also wrong sometimes, but
Yeah.
since I mean you have went through that, I also shared a document with you.
Mm-hmm.
Please go through that and just let us know if let me know if I am actually felt. I
Yeah,
mean,
yeah,
I
yeah.
took it in a different way or what. Okay.
Correct, correct. Yeah, it is good only actually if you revisit again and go through it. Yeah.
Yeah, sure,
Yeah,
sure,
correct,
Rajesh.
correct.
Thank you,
Okay.
Rajesh.
Thank you. Yeah,
Yeah,
thank you. So today, yeah, thank you. Today we are going to see about the daemon set, about the scheduling topology. These are very small topics. So then we have a affinity and anti-affinity. We'll also discuss today something on static pods. Like it's a very small topic, but it is better. We should know about these things. And we have something as RBAC, role-based access, role-based access control. So this is what I'm thinking to cover up today. If time permits, what we will do that we will even have the topic, which is nothing but probes actually, which we are supposed to take last session, but we didn't take probes, right? So in the probes we have a readiness probe and readiness probe, and of course one more topic is there, horizontal HPV, say, horizontal pod autoscaler. So of course we will not be able to cover these things today. I mean these things, but in the upcoming session I'm saying. Okay, and again we have Kubernetes volume, and we have the ninth session. What we have is a config map. Map and
सुनो सुनो पापा देखो देखो जब भी हम लोग को ये देखो जब भी हम लोग पिंक और ये येलो को ऐसे मिक्स करते थे क्या बनता है
green.
क्या
Green one. Okay, guys. So this is what we are having. Some of the topics actually. So once we complete this, see, these are the major things which we have to cover in the Kubernetes. And once we cover this, we are almost near to the end of the Kubernetes actually. So and after that, we have many other topics like we have a Helm, which I was saying, right? Helm is there as well as integration of like Grafana with the Kubernetes. Okay, and we have like Kubernetes in AWS, which we call EKS, and as well as in Azure, which is AKS, and in Google and the Google Cloud Platform, we have something GKE. And of course, like as I said, like we will be doing some troubleshooting also. One session in troubleshooting, so that we will troubleshooting we will see it actually. And one more session with what is left, sir? Anything is there, so that Kubernetes in AWS troubleshooting, and of course we will discuss about the CKA, Certified Kubernetes Administrator. We will see it actually, but
Prometheus and Grafana.
yeah, that's what Prometheus and Grafana is this issue. Yeah, Helm, and we have Istio. We will see, sir, actually, because I didn't get a good document or something to study on it. But yeah, I've got some few video reference, so I will see it. If I get it to know, I will do this Istio. So this is one important thing. So this is pretty much, sir, whatever we are covering. This much is more sufficient for us to have a good understanding of the whole like service mesh and Istio. That's what I said. I'm not able to get the proper document of not document. I'm not able to get some particular note or something where I can able to update. But still, I'm trying my level to best understand. Okay, I have learned. I have understood something on Istio, but that is not sufficient. So I have to still some more thing I have to dig into this. Helm itself will take some 2 sessions. Very important Helm. So this we should know very well actually. Okay. So I think most of the things which I have told, like we will be covering, sir. Okay. And this and all, right? No, what I'm saying that Kubernetes in AWS, that is under EKS, right? So this is a huge topic, sir. Again, like I don't know how far I will be able to justify this. I can only able to tell you like how to install, configure, set up your Kubernetes in EKS. Same thing, the Kubernetes in EKS and Kubernetes in GK. Only the setup part and showing some few deployments into that. That I will show you. Rest all other features, right? You have to learn by your own actually. You will not be able to cover each and every like PaaS service in each and every cloud in detail. That's not possible. Okay, sir. Anything you missed out, sir, which is coming to your notice? I think I have almost mentioned everything, whatever you want to cover. So we will see, sir, how far we will go with this actually. But today, let us focus on completing few topics. Okay. Now, now, so today we are going to learn about the DaemonSet actually. What are DaemonSet actually? We know very well that in a pod we learned something on the replication controller, right? Replica set, RS, and also we learned about the deployment. You remember, right? We use these services to to create some kind of a controller, right? So even DaemonSet is also a kind of a controller itself, which you can do it in pod. But so when we are going to use the DaemonSet, okay? For example, we want that one of the monitoring pod must be running on all the nodes in the cluster all the time. We assume that actually you have like you have a cluster, and within a cluster you have a node, like we have a master node, right? And we have a worker node 1, worker node 2, worker node 3, right? Now here what happened, right? In each and every node you have some kind of a pods which are running, right? Like assume say that you are running some Apache pod actually, or else you are running some web server patch, which is Apache patch. Apache pod is running here. But at the same instance, what happened then in each and every node, you need a pod where it has to do the monitoring activity of this Apache. So you need to have one more pod, okay, where in each and every node, this pod has to be automatically get created. Okay, it depends upon the number of worker nodes. Here you are having 3 worker nodes. So each and every worker node, you need to have one pod, so that this pod will act as a log monitor. So whatever the Apache is doing, it has to monitor whatever the Apache is doing. So how it can monitor? It will go through the log of the Apache, what it generates, and it want to monitor it. So in that case, what happened, right? You need to create the pods actually. Okay. So in that case, what is happening that it is always better to choose DaemonSet. DaemonSet is also one type of a deployment itself. Deployment. It is not exactly the deployment. It's a kind of a deployment, right? So what will happen that in each and every node, a pod will automatically get created. Suppose you say that I have a worker node 5. I have 5 worker nodes actually. Okay. And you say that actually I want to create the deployment, and I need 5 replicas. 5 replicas. Now, guys, you just tell me, like I have 5 worker nodes, and you say that I want 5 replicas. It means that I want the 5 replicas to be created in those 5 worker nodes. Now, how does exactly the scheduler will schedule the pods? Do you think that the scheduler will schedule all the 5 pods, 5 replicas in all the 5 pods, or how it is actually? Suppose there is no rule set for the scheduler to schedule it. There is no proper rule set. Assume the scheduler can schedule anywhere. So in that case, what is happening that the scheduler out of these 5 replicas, right, or 5 pods. So suppose there are 5 pods are there, assume that, and it will get to know that one of the node is having a very high CPU and very high memory. Then what the scheduler will do? Scheduler can schedule 1 or 2 pods into that one node, 1 pod in one more node, and 1 pod in another node. Right? In that case, out of 5 worker node, the scheduler can schedule all those 5 replicas in only the 3 nodes only. Right? The other the other 2 nodes might be vacant, where it might not create the pod at all. Correct, sir? So we cannot really understand the behavior, or we cannot know the behavior of the scheduler, right? Correct? Do you agree with me? See, it is possible that if there are 5 worker nodes are there, if you are saying that I want a deployment of 5 replicas, definitely it might create one single pod in each and every working node, 5 working node, right? In that case, what happened, right? You are able to see every node, you are able to see one pod. Correct? Do you agree with me? But the probability might be that actually that it might not schedule in every node, it might not schedule one in whichever node which is having more memory, more resources, like more CPU and more RAM. Maybe in that node the scheduler might schedule more than 1 pod, so it might schedule 1 or 2 or 3 in a single node itself. In the other rest 4 nodes, it might schedule one. In that way, what happened, right? Here, what happened, right? You don't have a control over the scheduling of the pods, right? The scheduler will best decide how to schedule it. But when it comes to the DaemonSet will make sure that every node will have a single pod created. That is what the requirement. As I said, right, we want to have at least one monitoring pod to be run in all other nodes in all the time. In that case, you have to choose the replica set. Clear, sir? Any doubts you have? So it depends. So what it says that actually DaemonSet. See, if you define, if you want to really say, you can say like this: DaemonSet is equal to, means the number of replicas what it creates, it is equal to number of so DaemonSet is the number of replicas are equal to number of pods. Right? Number of pods. Yes, sir. Any doubt you have, sir, with this? Did you understood the concept of DaemonSet? See, in case of a deployment, in case of a replica set, replica controller, anything, right? The scheduler can schedule the pod. It depends upon the scheduling methods, or it depends upon the scheduling topologies. It depends upon that. Whereas here in the DaemonSet, it will make sure that each and every node will have a single pod created. It means, see, assume that now if I go to my master node, if I say kubectl get pods, now you could see that actually not get pods, get nodes. Get nodes. You could see that there are master node is there, worker 1, worker 2, and worker 3 is there. Correct? Now what is happening is that actually that if I create a deployment set, say if I say that I will create 5 replicas actually. I want to have a 5 replicas actually for your DaemonSet. So now what is happening over here is that actually in case of a DaemonSet doesn't work. Replica doesn't apply to the DaemonSet. Because what is happening that here the replica set doesn't come to the picture when you are talking about DaemonSet actually. DaemonSet will talk about every node, or every node will have one pod created in that. Suppose tomorrow I'll add one more node actually, 4th node I'll add. Automatically in the 4th node also, okay, one pod will get automatically will get created. You need not to create it automatically. Suppose I create one node, I will set it up and I'll join that node, and here you could see that worker 4 node joins. If assume that in all these 3 nodes already deployment set is running, if you're adding the 4th node, even the in the 4th node also, the pod which was created through the deployment set will be recreated automatically. You need not to do it actually. Similarly, when you delete the DaemonSet, all the pods which are running in all the nodes will get deleted. So if you delete the DaemonSet, all the pods which are running in all the nodes will get deleted. Clear, sir? Any doubts you have here before we proceed further? Before we proceed with the example, let me know, guys, if you have any doubts. I hope you understood the concept. Okay, guys, are you there?
Yeah,
Yeah, sir.
You understood what I'm trying to tell you, or any confusion you have? Because no, okay. So now, so what is happening is that here, if you want to see the example, okay, I have just a second, guys. Sorry, I'll be back. Hold a second. Okay. So if you see the example of DaemonSet, right? I've already written an example, YAML file for the DaemonSet actually. Here you have a DaemonSet. Okay. Now you could see that actually, if you copy this file, okay, I'm just deploying using the DaemonSet actually. So I'll copy it. So now what I'll do, I'll go to the root and I'll say something deployment.yaml. I'm able to copy this. Okay. Now you could see that actually here what is happening here. You could see that you have API version apps v1. You have a kind, instead of deployment, you are having a daemon set. And in the spec, you don't have a replica. So we need not to mention the replicas here when it comes to daemon set. Okay. And here in the metadata, you have a pod name, and here you are mentioning the label. So whatever the pods which are getting created, that will get the label as app is equal to nginx something. And again, the spec here, as I said, here you are not mentioning any replica. So that is a difference you have to say. If in an interview they ask you what is the difference between daemon set and the deployment, actually this is the spelling is wrong, DPL or deployment. So what is the difference between daemon set and deployment? You have to say that in the daemon set we will be mentioning the replicas, but whereas here in the daemon set we won't mention the replicas. See, if you see the deployment, suppose if I go with any deployment, see, if you see the deployment, we could see that these replicas are there, right? So it means that while running this deployment, you need 4 replicas. It means that you need to have 4 pods getting created. But whereas in daemon, here you know to mention. This is one difference you have to tell. Okay. So after that, you could see that you have been having a selector here, and you are saying that you are actually matching the matching with this label app nginx, and here in the template also you are mentioning about the label, and here in the spec you are having a container, and you are mentioning about the container and the port which it uses. So this is what the daemon set. So let me apply it. kubectl apply F deployment. Now if you see kubectl get all -o void. Can you see here, guys, that see this deployment, see it has created a pod with the name nginx on all the worker nodes. See worker 1, worker 2, worker 3. Right? Now you could see that actually it has not created any replica set. It has created its own daemon set actually. You know very well that, right? A replica set will get a replica set. Okay, the deployment. Uh, when you're creating a deployment, right? A deployment, what happens? The deployment is going to create a replica. It will have a replica set, and that replica set will monitor all the pods, right? You remember, right? In the services we learn, right? Whereas here, there's nothing like a replica set. Here we have a daemon set. This is one difference I would say. There is no replica set comes when you are working with the daemon set, because daemon set itself will monitor all these pods. Even though if you try to remove this pod, okay, kubectl delete pod, specify this pod name. Okay. The pod will get deleted, but again it will get recreated. See, again it will get recreated. So what is happening? That who is monitoring this control of this pod and everything? The daemon set itself will monitor. Whereas in case of a deployment, replica set anywhere, replica set is to monitor actually. Correct? So this is the second difference you have to say. Okay, guys. Now, so this is the simple topic. So this, it says that actually you could see that actually in the deployment set, see it has a desired of 3. Why it is saying 3? Because there are 3 worker nodes are there. Suppose if there are 2 worker nodes are there, the desired set will be into 2, because in each and every node there will be only one single pod will get created. Right? So in case of a deployment set, you know very well that every node will have a pod get created. It will be created in every node actually. Fourth node will get, if you attach one more node, fourth node, even that node also replica, daemon set will going to create one pod actually. Okay. So this is one thing. Now, one use case in our system, like for example, if I give kubectl get pods, if I say -n cube-system, okay, -o void. Guys, if you see here, now you could see that there are some pods are there which are there in all the nodes. See, for example, kube proxy, can you make out here? The kube proxy is there in a worker 1, worker 2, worker 3, as well as master. Even here, the weave network, you could see that it is having in all the nodes, worker 1, worker 2, worker 3, worker, and the master. Now, what you can tell out this one, if anyone asks the use case, you could see that in the system itself, there is a daemon set which is running. So those daemon set are for kube proxy and weave network. Now, if you want to prove it, you can take kubectl get all -n cube-system -o y. Now you could see here, see the daemon set for the kube proxy. See, it needs 4. Why? Because you are having master also, master, worker, output. So totally there are 4 nodes are there. For that reason, it is maintaining the 4 design. That's the reason you could see that the kube proxy is there in all the 4 nodes, including master, worker, output. Similarly, if you come here, you have a weave network. Why you have a proxy in all the? Because you know that the pod will get scheduled in any of the node, right? Pod can even get scheduled even in the master also, right? Because now we have a tainted flag as a no schedule. That's the reason pods are not getting created in master. Assume that you remove the taint. Even when you are applying a deployment, if there is a free space in the master itself will allow to create the pod within it, right? So once the pod is getting created, an IP address has to assign to the pod, right? Who is going to assign? The kube proxy will assign. That's the reason what's happening, that this daemon sets, these pods are there in every node, including master. Similarly, weave network also. Weave network is a network topology. Means that whenever you need any networking stuff, you will get through the weave network. That's the reason these two are very important. This is a use case you have to tell in an interview. Clear, sir? Okay. Now, if you go to the net and if you say DaemonSet, or Kubernetes DaemonSet, see, excuse me, see, the DaemonSet ensures that all or some nodes run a copy of the pod actually. As nodes are added to the cluster, pods are also added to them. That's what I said. Even when the 4th node is getting added, automatically, if whatever the daemon set is running, right, it will even schedule even a new pod into the newly joined node. As nodes are removed from the cluster, those pods are also garbage collected. Means that those pods will also get deleted. Deleting the daemon set will clean up all the pods it creates. What are the use case of the daemon set? See, running a cluster storage daemon on every node. In that case, you will be using daemon sets. Running a log collection daemon on every node. In that case, you'll be using daemon set. Running a node monitoring the daemon on every node. Then you use the daemon set. Clear, sir? Now, this is the example. Okay, this example. Go through this example, and then we'll be understanding about the pod selectors and everything. This and all we'll be understanding later actually. How the daemon pods are scheduled and all. We'll be seeing the scheduling and all later actually. So this taint and all we already studied, right? Tolerance and all we have to see later. Taint we already understood. Like we can set a taint flag, right? So this is all about. So you just go through this document, and static pod we will see. We'll see later. Today itself, after some time we will see what is static pod. So you can go through this document. This is good. So this is just a small topic, but we have to know what is a DaemonSet. Clear? Okay, sir. Now next is nothing but you have a something on a scheduling topology. I'll do one thing. Let me remove this running part. kubectl delete -f deployment. Okay. So the next topic is scheduling topologies. What is the scheduling topologies? Okay. So now a question comes actually, like how exactly the Kubernetes schedules the pod actually. You know that whenever we create a deployment, we run a deployment, right? Basically, what it will do that it will create a pod into the existing or into all the worker nodes. It based on the depends upon the scheduler actually. So scheduler it follows many of the topologies, sir, but few of the important topologies are something like node name. Node name is there. Even we have a node selector. Okay, and we have something like cordon and uncordon. Like this. These are some few of the scheduling topologies we have. So what is a node name basically? You can mention the node names. Like for example, here, if you come to over here in our deployment, it's in our this example, you could see that node name. See here, if I copy this program or YAML file, I'll copy this YAML file. So if I execute kubectl get pods, there are no pods running. Okay, fine. Now I'll do one thing. I'll say node name.yaml, something like that. So I copied it. So just insert it. Now you could see that it is a deployment file. The kind is deployment. The whole YAML is same as what we used to do earlier. But here what happened in the spec and specifying something is node name is worker one. It means that whatever these four replicas are I want, that has to get created in the worker one node only. Even though you are having a in my system, I'm having worker. There are three worker nodes are there, right? There are three worker nodes are there. But here what happened in your spec file, you are explicitly saying node name is worker one. It means that actually you are saying that all those four replicas has to get scheduled into the particular node, into a particular node itself. Because this is a node actually. See, yeah, worker one is a node name actually. So here, this is what I have mentioned over here. So let us run this YAML file and see how it behaves. kubectl apply -f node name.yaml. If I execute kubectl get pods -o wide, I could see that all these four pods, engineering pods, see, they are scheduled in the same worker node. Correct? So, but this is just one of the scheduling topology because here they are in your YAML file, you are mentioning where the pods has to get scheduled actually. But in the real time or in the production time, right, in the production side, this is not a recommendable. You should not use this actually. Okay, so you can schedule either through the name of the node or either through your node selector. It means that suppose you provide a label, you say the label. See, but the disadvantage over here is that actually the problem is that actually you can give only one node name at a time. You cannot give saying that no, this engine has to even get created in a worker to worker three also. There is no provision here. So here what happens? The disadvantage is that you have to specify only one node actually. So that's what we said. Node name is worker one. So this is a disadvantage. Hence, this is not a recommendable to be used in the production side, but still, this has to be thought. That's what I'm saying. Okay, so that is what it is. Now, what is happening is that the next is a node selector. Node selector means suppose your node has some label. Actually, this node has a label, something like disk is equal to SSD. This node has label as disk is equal to SATA disk, right? Disk is equal to SATA. So if you say like this, actually, here what happened that you are assigning a label to that node. Actually, we have even learned about this in the label also, right? So based on your node selector, you say that okay, whatever the important part. Suppose assume that you say that Rajesh, I want to, like I want to run, I want to generate a MySQL pod with the help of a deployment, but all those MySQL pods has to get created into this node where it is having a node selector as a SATA, disk is equal to SATA. So because maybe the second node, worker node 2, might be having high configuration. That means it is having more CPU, it is having more memory. So in that case, what happened that whenever you want to create a pod of, I mean, where you want to run a MySQL inside a pod, which requires a lot of memory and CPU, under that case, you can mention as a node selector. So that is the second point. That's the second point. Clear guys? Node selector. So here what is happening, if you see an example here, what you have to do here is that actually you go to the root, you have to go to the master. Sorry, what you have to do that, you have to say kubectl sorry, node label node worker 1 disk is equal to SSD. So that's saying a label, right? Similarly, kubectl label node worker 2 disk is equal to SATA. This is a SATA disk. Because that you have set the label where the worker node has a disk drive which is a SATA type. Here in the worker one, it has a disk type which is SSD. SATA disks are faster than SSD disk actually. The working the IO, right? Input output, input output, numbers are very high in SATA disk actually. So here what happened? I'm just assign a label to it actually. So now if you go to the program here, you have a node selector. Same thing. I can copy this whole program. Let's just say node selector .yaml file. Now you could see that very well under the spec you are having a node selector. So in the node selector you are mentioning very clear that the disk should have a type SATA. It means that it will look for the node which is having this label as a disk SATA. And for the worker 2, we saw very well that we have already set this label, right? So let us see if kubectl get pods, any pods are running. There's a pods are running. So let me remove this pod. So kubectl delete open F node name .yaml. So remove it. Okay. Now if I take kubectl line -f node selector .yaml. So now you know very well that kubectl pods -o while all these pods, 4 pods have been scheduled in worker 2. So because here we have set the label as a disk is equal to SATA. So where did you mention as a node selector? You mentioned inside your spec itself. See under spec you have this field which is a node selector. Here you have to do the node. Okay guys, till here it's easy, right? Pretty easy, right? It is not that difficult to understand, right? Correct?
Yes, Rajesh. Yes, Rajesh.
Yes, it's very simple. All these are simple topics. Okay, so that's what. And the next what we have is a cordon and uncordon actually. Cordon is something like where you don't want to schedule any of the pods to be created. Then you can say it is a cordon actually. So this is also used heavily. But here what is happening is that you could see that actually, let me first delete the deployment. Now, if you say, suppose you have a kubectl get nodes, and you say that Rajesh, the first node is having a heavy memory crunch, or CPU, not much CPU is available over here. So you don't want to schedule any of the further new pods created into it. then in that case you can call it, you can make it as a cordon. How to make it cordon? You can say kubectl cordon, cordon cordon, and you can specify the worker name, worker one. So a cordon. Again you say kubectl get nodes. Now you could see that scheduling is disabled here. Okay, so whenever you are scheduling anything now, suppose you are having a deployment, you are scheduling now, it will not schedule into the worker one now. It will always schedule to the worker two and worker three. Once the issue is resolved, right, you can uncordon, you can remove so that the new pod, but whatever the pod which are already running under the worker one, that will not get disturbed. That will always be there. Any new pod will not get scheduled into this cordon, or into this worker one, because you are corded. You are disabled the scheduling. Clear, sir? Now again, same thing. If you have a get.yaml, if I go to any of the deployments, suppose I go to the old deployment itself. So here you are saying that I want the replicas 4 actually. I'll save this file. Let me first check whether any pods are running. No. So now I'll set kubectl apply -f get.yaml. Now we say kubectl get pods -o y. You could see that actually it has not scheduled in worker one because you are coordinated. So this all these 4 pods replicas are been divided in worker 2 and worker 3. So this will also, it is just to show that how you can schedule any creation of a pod into the node actually with the help of this scheduling topologies. Okay, so here, but the point here is that some people have asked this question actually, like here, even though you are cordoned actually, you could see that here kubectl get what is it? Get pods, get nodes, get nodes. Even though you have scheduled, you have corded it where there is, it has you have seen the flag is scheduling disabled. In that none of the pods will get scheduled into this worker one, right? But still assume that actually you are having this actually. And here what happened, you could see that you have mentioned the node name selector as a worker one only. Let's see whether it will create or not. So it means that even though you coordinate, you want the 4 replicas to be created in the worker one only, even though you have coordinated. So now what happened, right? This node selector, this node name, right? It has a high priority than this coordinate actually. Even though it is saying this scheduling disabled, but still you will see that it will apply that way. It means that all those pods will get created into the node one. See, kubectl get pods. Here. So even though there is a crunch, but still what happened, right? It depends upon whatever the available resource is there. With that, it will try to create it. If not, it will be, some of them will be in running state and some will be pending if it doesn't get the proper resource. But what is happening that in this case, the node selector, the node name, right, in the spec, right, you are overwriting the coordinate actually. You are overwriting the coordinate, so it will still allow it to create. This will happen only with case of a node name, not with the node selector. Suppose you say that Rajesh, same thing here in the in your okay, I don't think I will kubectl node name.yaml. Now you say that actually Rajesh, I have the node selector actually. Here what I'll do, I will say it as a disk as a SSD, right? Because this is in the first node is having a SSD as a flag, right? Label, right? Correct, sir? Now let's see whether it'll lower it or not. This lower, I think this will not overwrite it. Only the node name will overwrite. Kubectl apply -f node selector .yaml. Let's see, sir. Kubectl get pods -o. All are pending. It will not overwrite because here what happened, right? Whatever you have this get nodes, see, it is in a scheduling this. It is coordinate. Hence, it is not allowing it to create into the worker model. Okay. So node selector will not work when it comes to coordinate. Node name will supersede or override this coordinate also. Okay. These are just use cases, sir. Actually, like, what I would say that actually it is, these are there, so that's what I'm saying it actually. If you ask me the use case and all, yeah, I mean, we have to just check where exactly it is used, but these are there actually. But that's what I said, like node name will not be used in the production side. So hence, just for a knowledge purpose, I'm just telling you all these things. Okay, a real use case, if you ask me, I don't think any kind of a much use case is there for this. Right? Do you agree with me? Right? Correct? Do you agree with me?
Yeah,
Or you
got
have
it, Rajesh.
something in your, or you have something in your mind? Okay, there could be some use case. If you have some use case, you let me know. I'll also get to know about that. But I don't think that any, I mean, it would be there, but as of now, like when I went through document, they have not mentioned anything like that. What is use case and all. So like that and all, right? So they are not mentioned it. Even you can say Kubernetes, what is it? Scheduling topologies. Or topology spread constraint. You will say you will get to know everything, sir. All these things. So they have mentioned it actually, but a few of the things they are not given any use case. Only they have mentioned it. So I read this document very well. So that's all. Okay. So you can go to this document, sir, later. Okay. Okay. Let me unconnect it. Important. Schedule. CPL. Okay, sir. Okay, guys. So this is what. Okay. Now we have completed the topology and DaemonSet actually. Now we'll go with the affinity actually. Affinity and anti-affinity. Okay. Now, what is affinity? Affinity and anti-affinity. Now, suppose, assume that you want to run Apache, okay, into your Kubernetes cluster, okay, and there are four in your cluster. Assume that there are four worker nodes are there, okay, and you want to create an Apache, Apache. You want to create an Apache pod into all the four nodes actually, okay. So it means that you want to achieve the high availability. So guys, what is by high availability means? Suppose, for example, suppose if you go to this diagram, suppose you say that okay, Rajesh, I want to create a deployment of 5 replicas, okay, into these 3 nodes or into the 5 worker nodes, or assume that I want to create 3 replicas. So I'm just taking this example. So I want to say I want to create 3 replicas of your Apache, okay, okay. So now, when you create a deployment, in the deployment, you mention that you want the replicas of 3, and when you apply it, and there are 3 worker nodes are there. There is no guarantee, right, that all these 3 pods will be scheduled in all these 3 nodes. There is no guarantee, right? The probability, there is no 100% probability that all these 3 pods or 3 replicas will get created in all the 3 nodes, right? So maybe there might be a chance the scheduler might schedule. It might schedule all the 3 pods in all the 3 nodes. That could be the case. Or else it can schedule 2 pods in this node. So in these 2 pods, This out of 3, from 2 pods it can schedule over here, and 1 pod it can schedule over here, right? So it has achieved these 3 replicas. Now, how do you say that you are maintaining the high availability? When you say that in your whole cluster you are having the 3 nodes actually, right? Suppose that this node was up and running, this was giving a service to a customer actually. Suddenly assume that this pod goes down actually. This pod goes down. Then still what happened, right? Your application availability will be there because here 1 pod is running in this disk also. So it is available. Oh, you can say that you are achieving high availability. But assume that again what happened, right? This disk also will go down. If this disk goes down, what is happening that you could see that all your pods got killed. And here in this node, there are no pods running. So in this situation, you cannot say that you are achieving a high availability. Assume that actually what happened that these 3 pods, or you need a 3 replicas, and these 3 replicas got created in all these 3 nodes, 1 in each and every node. In that case, you can say it as okay, my Kubernetes cluster is providing high availability. Why? Because on each and every node there is a pod running. Even though this pod get deleted, even though this pod get deleted, but at least this pod is there, right? Where my application is running here, right? So in this case, we can call it as a high availability, actually. So in practice, if you want to achieve a high availability, assume that I am having some 50 worker nodes are there. Okay, some 50 worker nodes are there, and you want to create some 50 pods, right? Apache pods, right? So then what will happen that actually that if you are, so what is high availability? The definition, all the pods must be running or must be scheduled together in all the nodes, right? Now, how you can do it means, now what is happening that you are not sure here at the beginning that whether all the nodes will get equal number of pods. You are not sure because it depends upon your scheduler. The scheduler might decide to create 2 pods in only 1 node. So the chance might be there that this every node might not get. In that case, if you want to make sure, whatever case might be, you say that whatever case might be, I want to have a high availability in my entire Kubernetes cluster. It means that every node should have a running pod of whatever a user is requesting. In that case, you have to use an anti-affinity. What anti-affinity says that? What anti-affinity says that actually? What it says that actually? It will make sure that pods are scheduled in all the different nodes. So that's what I said, that if you're having 4 worker nodes, assume that here you're having a 4 worker nodes actually. You're having a 4 worker node. Okay, you're having a 4 worker nodes, and you say that actually in the you say that actually that Rajesh, you will say that okay, I have 4 worker nodes, that's fine, but you say that I want 2 replicas of my Apache to be running. Now what will, and if you're using anti-affinity, the anti-affinity will make sure that these 2 pods will always get created apart in different nodes. It doesn't mean that in only 1 node this 2 pod will get created. If you're using anti-affinity, right, it will not allow 2 pods to be created in only 1 single node. It always make it apart. It means that the pods will get created always in a different nodes actually. So this we call it the anti-affinity. Now some people you might have, say DaemonSet, what will happen that it will always create a replicas of each and every node, right? It depends upon the number of nodes. Here what happened that you are having 3 nodes are there. So DaemonSet will make sure that in each and every node there is a pod getting created actually. But again what happened right here, what happened in the DaemonSet, replicas doesn't, right? In that node also you will get pod get created. But whereas here what is happening that in case of anti-affinity, here it uses the replica set. But what happened right in each and every replica set, what is happening that it will distribute the equal number of pods. Assume that now you are having in each and every node you are having one pod actually. Okay, Assume that one more node is getting added actually. One more node, new node you're adding. One more new node you're adding actually. That's a fifth node you're adding. It doesn't mean that in the anti-affinity it will create here one node, in one pod here. No. Whereas here in this case of a deployment, you are, as soon as you're creating one more worker node, a new pod will get created. That is the DaemonSet pod. So that is the difference you have to say. If they ask the difference between as if like both look same actually. DaemonSet as well anti-affinity, it looks like same, but they are not same actually. So there it doesn't follow the replica. Here it follows the replica. But here, what will make sure that two pods together will not get created in a single worker node. Always it get distributed across all the nodes, whatever are there in their cluster. So here you would say that Rajesh, I have a 4 worker nodes. You say if I'm giving the 4 replicas of your Apache, then four pods will get created in these 4 different nodes. So to make sure that to attain a high availability, anti-affinity is not but to achieve the high availability, you use anti-affinity. Clear, sir? Okay. Now you say that okay, this is fine. Now you say that now you will create one more pods actually, which is of Redis actually. You need to create a Redis pod. Okay. So Redis are put in memory database, right? Redis pod. Now you say that Rajesh, I want to create 2 replicas of your Redis pod. Okay. See, just for your understanding, you took 4 actually, but assume that in case of Apache, I want only 2 replicas actually. So even though there are 4 nodes are there, so what is happening is that these 2 replicas of Apache are got created here, right? It got created. That's fine. Now what happened, right? Now you want to create a Redis pod, which you want for 2 replicas. Okay. Here, what is happening that you have a 2 case actually. You have a 2 requirements whenever you are creating a Redis pod. What is our requirement is that actually you need to maintain a high availability even for Redis pod. It means that you say that Rajesh, when I'm creating a Redis pod, those 2 replicas should also not get created in a single node actually. They should be apart. Okay, that is fine. It means that you need to what is it? You need to apply a anti-affinity. Correct, sir? So here, for the Redis pod also, high availability means you need to mention the anti-affinity you need to apply. Okay. As well as the second requirement is that actually, what is the second requirement you have? The first requirement, okay, I want to have a high availability. It means that I need to apply the anti-affinity. But what is the second term? So what is second means actually the Redis pod must be running onto the worker node. Means it has to schedule onto the worker node where one Apache pod is running, which we call as affinity. So what it says that actually, even though I need a higher availability, it means that I need to have anti-affinity means those 2 Redis pod, it should get scheduled apart. It means that in one single node, 2 pods should not get created because I need a higher availability. Fine, you need to apply anti-affinity for Redis pod also. Fine. But the second condition, what is saying that Redis pod should be created or must be running onto the worker node where one Apache pod is running. Means here you could see that this Apache pod is running. This Apache pod is running here. And here also the Apache pod is running. What he says that Redis pod should get created into the node where the Apache pod is running here. So this is nothing but this is a Redis pod. This is a Redis pod. So whenever you want to achieve that, it means that how you can achieve basically, sir, you can achieve with the help of a label only, right? You can say that okay, this Apache pod which got scheduled, it must have been scheduled with the node selector with some label it has got created, right? So you have to mention while applying for applying for the Redis pod that whenever you want to apply for Redis pod where you want to create 2 replicas means here what happened, you have to mention that it has to get created to the node where the Apache is running. So in that way, you need to apply the affinity. You got these 2 things, sir, 2 different things. You got it right. So why we are doing this? Because right, to reduce the latency, it means that Redis pod will be dependent upon the Apache pod. Here also Redis pod is dependent on the Apache pod. right? Now what is happening is that actually that if you suppose assume that you are not applying the affinity, you are not mentioning the second point, then what happened that the scheduler might schedule the Redis pod here also and here also it can schedule. It means that these are two free pods, right? Two free nodes, right? Which running. It can schedule here also. No doubt here also what happened, right? The Redis pod will get created, but what is happening that the Redis pod want to communicate with the Apache pod means you will see some kind of a network latency here. So to avoid this network latency, to make sure that actually the same node where the Apache is running, in the node only I want to have this Redis pod to be created, then in that case you need to apply the affinity. Clear, sir? Clear? You got the requirement, right? So this we call as affinity, sir. So this is very, very useful even into the production. This something, if you remember in the last class, something like we discussed about the Kubernetes sidecar, right? It acts like something like that, right? Because you are creating the Redis pod into the pod where into the into the node where actually the Apache is running like this. So this we called as an affinity. So if you go to the Google and if you say that affinity and anti-affinity Kubernetes, you could say that here anti-affinity, right? So here it says that actually you are having a node selector. We just discussed about node selector and all, right? So if you come down, okay, come down, you can go to this document. Okay, I'm more interested to see the example actually here. If you come down, okay, yeah, here you have something known as a Redis cache actually, Redis pod actually. So let me do one thing. Let me copy this actually. Copy this. So here I go. Pods. Nothing is there. So, see, for everything, sir, whatever you do, you can do it in your own namespace. So first you have to create a namespace and do all the apply in the namespace. That you can do it actually. Here I'm doing in a default namespace. That's all. Otherwise, if I for every example you can have your own namespace, right? So or else I have copied it here also. The same examples are here also in the affinity and anti-affinity, right? Here you could see that I have copied this actually anti-affinity. So this is what I have copied it. The same programs are here. Whatever you have copied, no, same thing here also. That's the same program I copied. See, same thing. So VI anti-affinity. Okay. Now you could see here that actually you are using a deployment. Okay, and you are creating a metadata and the name of the pod is retrieve cache. Fine. Here you could see that you are using a label. Okay, of a label is number app store, means app is equal to store, and you are creating a replicas as 3. Yeah, okay. And in the template you are having a metadata. Under that you are having label also mentioning the same app as a store, app equals equal to store. Okay, that is a label you are mentioning. And in the spec actually here what is happening that you are having the affinity. Okay, under the affinity you are having a pod affinity. Okay, so that's what we want to achieve, the pod affinity, pod anti-affinity, sorry, anti-affinity. And here what is happening that you have one like we have one field as a required during scheduling, ignored during execution. Okay, we will see later what is this meaning of this one actually. So this is one of the fields required during scheduling, ignored during execution. Okay, under that you are having a match expression as a label as a store actually, and here you are having a topology of your host name. You can even give the host name or even you can give the label also. Okay, and here in the container you are actually creating a Redis image, Alpine image you are creating. Now here what is happening is that you want the replicas as 3, correct? And we know very well that here we are having a nodes. How many nodes we are having? 3 worker nodes are there, right? We are having a 3 worker nodes. Now here what is happening that you want the replicas as 3. Okay, now what it will do that it will schedule this Redis pod, right? This Redis pod, right? In all this 3 worker node, worker 1, worker 2, and worker 3. But assume that I'm having a 4th one. Suppose assume that I'll say Rajesh, I don't want 3, I want 4 actually. I want 4. let's see what will happen. Now, if you execute kubectl apply -f anti-affinity, what anti-affinity states that make sure all the pods which are scheduled in all the different nodes, means that every pod will get created in all the nodes. But here, what happened, right? We are having a 3 worker nodes, but we want replica 4 actually, 4 replicas. In that case, what will happen, that it will say that one replica or one pod will be in a pending state. See here, kubectl get all -o y. See, can you see here? In a pending state. See, it has not got scheduled anywhere because, right, you have mentioned the pod anti-affinity. So it means that here, see, in worker 1, one pod is got created. In worker 2, one pod is got created. In worker 3, one pod is. If you create one more worker node, worker 4, and then you attach, right, there it will get scheduled. Unless until it will be in a pending state. And I could see that selector is app store, right? That is a flag. No, that's a label it got assigned. And it is in turn uses a replica set and all. This is by default because it's a deployment type, right? So it have a replica set and everything. So here it is desired is 4, current is also 4, but 3 is ready and 1 is pending. So that's what it says actually. Now what it states actually, that if you see it says that required during scheduling, ignored during execution. What this field says that it is must that actually this pod which is created, it has to get created in each and every node actually. Because here you are having a replicas of 4 actually, there is a requirement actually that it has to get created in each and every worker node. But here replicas is 4, but you are having a worker node 3, so it cannot satisfy the condition. Hence, what happened? One of the pod will go into the pending state. That is what it states actually. Now assume that it says that it is required, sir. Required during scheduling. It means that it is a must actually. Assume that there is one more thing is there here. Here what is happening is that now it is required. It means that you are mandatorily making it. There's one more thing is that here. Like now the preferred actually. Preferred during scheduling, ignored. Like even this is also there, sir. Preferred, what it say that okay, he'll try to find it out. He'll try to find. If not available, if the node itself is not there, then the fourth part will get scheduled in any one of the other nodes. But whereas in the other there, required during scheduling, no required. It say that it's must and should that actually in each and every node a single pod should be created. Even though you are saying replica 5, replica 6, replica 7, because we are having 3 worker nodes, only 3 pods will get created. The 4th replica, the 5th replica, the 6th replica, 8th replica, whatever replica you want, that will always be in a pending state. If you are saying it as a required during scheduling, ignored during execution. If you say preferred, in that case, what happened? It will check. Okay, there are only 3 nodes. Are there? Fine. Let me first create. Suppose you are mentioned as 8 here, and you let first all the 3 nodes will get 1 pod, but remaining 5 where to get scheduled, because you have mentioned as 8. In that case, we don't have any other choice because there are no more worker nodes are there. In that case, we'll try to schedule the remaining 5 pods into this worker nodes. Clear, sir? You understood, right? What do you mean by preferred and what do you mean by required actually? So here you are having a required during scheduling. It is required means it is must actually. But if you say preferred, it doesn't have any choice. It has to create because it has to satisfy the replicas, right? So that's the reason it will allow to create into the other nodes. That is the meaning of it. Clear, sir? Okay. Now, so here what is happening is that it is still pending is there. Okay, fine. So we cannot do anything. We will say delete -f. What is it? Anti-affinity. Right? And if we say get pod, get over, nothing is there. Okay. Now, so let me do a thing. Let me run this again. Kubectl apply FNF, and if you execute the command, kubectl get all, so one will be in a pending state. Correct. Now what I will do that here, if you go down, you have one more example here. Okay, that example also I have copied here. What is it? You want to apply both anti-affinity and affinity. See, what is happening that if I copy this, let me copy this. So I don't think I will create a file anti-affinity plus affinity. .yaml. Both I want. So I understood this use case, right? The Redis pod which I was mentioning right here, because it has to get created to only in those nodes where the Apache pod is running actually. So that to make sure that satisfy that condition, you need to have apply the affinity actually. Anti-affinity, we know that in every node it has to create, because no two pods can reside in a single worker node. So that we call it anti-affinity. Why you are doing that? To achieve a high availability. So this is all doing affinity, everything anti-affinity because to achieve high availability, sir. That we discussed, right? So now what is happening that if you come over here and if you open this file, okay, let me copy this. I think I already copied it. I have to copy it, and you go to the insert mode. Now see here, if you see the program, it's the same kind of deployment. If you come over here, okay, anti-affinity, affinity is there, and below that you have a pod anti-affinity. Okay, in the pod affinity, what is happening that it is just checking whether, see, whether it is having a label. See, one more thing, sir, one more important thing actually, how affinity or anti-affinity will come to node. I should not schedule any pod into the other node actually. Means it should not schedule two pods running in the same node. How it will make sure? How the anti-affinity will make sure that in that single pod, two pods should never get created. Here in this case, like Apache, the two replicas should never get created in the same. How it will get to know? Because of the labels, sir, because of this key and the value. If it understands that already there is one pod which is already running with this app and web store, right? Then what happens is anti-affinity will make sure that it will not allow one more pod to be created. That's the reason what happened, right? It equally distributes in each and every node, sir. So because of this match expression, because of this key and value in itself. So here what is happening that the pod anti-affinity required during scheduling ignored, this is there. Okay, and this we are mentioning the key and the value. Okay, that is a label. And you could see that in the pod affinity, see, this is the pod affinity, anti-affinity. In the pod affinity, you could what it say that required during scheduling, ignored during execution, fine. And you could see that I want to create this Nginx actually. Nginx I want to create. Where I want to create? I want to create with those nodes where the there it is having the label of the app underscore actually. There it has to get created. So it means that this Nginx will get created into those nodes where already what is happening that the Redis pods are running actually. The Redis pods are running, so it will get created there. That's what it says actually. So if I apply it, HTTL apply, I can have anti-affinity plus affinity. If you apply it, you come over here and say kubectl applied. Now you could see that. So what it says that actually you could see that for your uh, web server for your Nginx, right? Actually, see here it has created the three pods because you are there. In that case, you are given the replicas as three only. You given the replicas as three only. In the anti-affinity and anti-affinity, you have given the three. That's the reason it has scheduled. But it has scheduled. See, it has scheduled where it has scheduled. It has scheduled wherever there is a app store, right? There it has scheduled those three web server pods. Otherwise, it could have scheduled. See, assume that this web server could have scheduled in only one worker node only, right? But here, what is happening is that you are mentioning that for the pod affinity, you want to schedule this pods where there is a match expression key and the store. So where is match expression key and the store, or app on the store? App on the store, it is actually running under the Redis cache actually. So here in the Redis cache, what it is doing, it is actually running in the worker 1, worker 2, and worker 3. There only in those three, in those nodes only, it will try to schedule it. So you are actually achieving both the requirement of when you are creating your Redis pod or you are creating any other pod, you are maintaining the both anti-affinity and affinity, both the things here in this example. So that's what I'm trying to tell here. Clear, sir? Till here? So if you go to the document of anti-affinity and everything, there they have said it very clear. If you come over here, you could see that for pod affinity, MTA topology is not allowed in both required during scheduling and preferred during scheduling, right? And here you could see that actually for required during pod scheduling for anti-affinity, the admission controller limit hot was introduced to limit the topology to the Kubernetes. So if you go through this document very clearly, you will be able to understand few things actually. Clear, sir? Okay, so this finishes our anti-affinity and affinity, sir. Any doubt you have, sir? Anything, any doubts you are having? These are some of the small topics, but yeah, it plays a very important role while learning Kubernetes. We have to know like all these things like node selectors, know how we can schedule the pod, as well as what is the affinity and affinity, what is a DaemonSet and all. We should know these are all small topics, but we should know the concepts very well actually, because we will be using these things in our in our real-time environment. We'll be using it, right? Here we are only learning the concept wise and few examples, but when it comes to real time, when you're working right there, you will see the most of the usage of this heavily in our real time. Correct.
Okay, sir.
Yeah. Okay. Now next is a small topic, sir. Like I'll take another 15-20 minutes. Then I think today we will not be able to cover this airbags, because airbags I need at least minimum half an hour to 45 minutes I need. This is very important, sir. This most of the time, not most of 100% of the time, the interview they will ask about the RBAC actually. So next topic we'll be covering is the static pods. Okay. Now, what are the static pods actually? What is the static pod? Okay, let me first remove these requirements. CPL anti-affinity. Okay, YAML CPL delete -f anti-affinity. Okay, nothing is there. Fine, sir. Now, what is a static pod, sir? This is also no. Sometimes they ask in interview, what is a static pod basically? See, static pod is something like if you execute a command kubectl get pods, it will say that there are no pods running in your system, right? But you know very well that if you execute kubectl get namespaces, you know that there are many of the system namespaces are there, right? You have something like cube-system. Now, if I want to check what are all the pods which are running the cube-system, okay, I will use the same command kubectl get pods, but here I have to mention -n and specify that namespace. Now, if I execute this command, you know that actually there are many other pods are there in your system. These are all system pods which are running in your system. You could see that your API server is running as a pod, okay, and you could see that your proxy is running, your etcd, that database is running, your core DNS is running, your view pod is running, your scheduler is running. See, these are all running as a pod, sir. All these pods which are running in a system, okay, in this namespace, these are called as a static pods actually. So static pods, if you want to tell what are static pods means, basically static pods are created when you initialize it actually. See, when you initialize the Kubernetes, right, you know very well that when I do a kubeadm init, You remember that it is going to configure and everything, correct? Now, during this cube initialization configuration, a lot of static pods are getting created. So these are basically system pods. Pods are always managed by the kubelets. Static pods are never managed by the master node. Master node in sense, like in the master node you are having an API server, right? API. So the static pods are never managed by the API servers. It means that these are not managed by the API servers. These are managed by the kubelet, because each and every node, like let it be a master node, worker 1, worker 2, each and every node, master, worker 1, worker 2, every node has its own kubelet agent which is running. So whenever those kubelet agent, if it creates any of the pod, right, into its system, and that pod will be called as a static pod actually. So it means that whenever the kubelet agent is going to create a pod, the scheduler which is running in your master, right, that will not be aware of this pod, sir. It will not do any kind of a control over the static pods. So it means that what I have to add, that scheduler is not aware of any of the static pods. Any of the static pod. It is not aware, because it doesn't schedule any of the static pod at all. So always static pods are always created, or even I have already mentioned here, are always managed, or but created and managed by kubelet agents running in each and every node. Now, if you say that, okay, Rajesh, if I want to check, now you see, if you execute a command, like for example, if you execute a command kubectl get pods or kubectl get nodes, how you will say that? Okay, the master itself is executing. How you are saying that actually the master itself is executing? Because in your master, all the pods are running, right? If you execute the kubectl get nodes, right, it is displaying some content that these are all the nodes. But how exactly say that you are the master actually? Because what is happening that in each and every node there is a config.xml file is there. What is the config.xml? /var lib, you have a kubelet. Here under that you have a file by name config.yml. If you open that, not XML, sorry, YML, config.yml. If you have a config.yml, now if you see this config.yml, and if you come over here actually at the end, you could see that there is one field of the static pod path, and the static pod path is etc Kubernetes manifest actually. Now let us go to this directory, etc manifest actually. etc just see under etc Kubernetes manifest, you could see that, see, these are all the YAMLs are there actually. So it means that whenever, so you could, whenever you see, whenever if I do the kubectl get pods, okay, -n kube-system, some of the pods which are get created like etc master, see, it got created with the help of this etc.yaml. Kube-API YAML. So the Kube-API server master, right, it got created with this. Similarly, kube controller, it got created with the help of this kube controller. So it means that these are the YAML files. Based on these YAML files only, these pods, static pods are getting created. And who creates these static pods? The kubelet is going to create the static pods. Now here, what happened, right? See, I have this four or five YAML, four YAML files there. Let me do a thing. Let me create my one YAML file. Let me create my own YAML file. I'm creating my own YAML file. Something. containers. Okay, my pod, and then we do that image. Let's engage. Okay. As soon as I create this pod, now if I do the kubectl get pods, why it is not getting created? You have to create an image that you take pod.yaml API version PRSI version v1 kind pod. Now it will create. Kubectl get pod. See, this pod got created. See, because automatically it got created, sir. Why? Because as soon as I played one YAML file, it got created. This is the static pod, sir. So this pod is not created by your API server. It got not created. It is not even scheduled by the scheduler. It automatically got created with the help of a kubelet actually. Kubelet agent is already running in your system in every node actually. So this is in case of a master, correct? This is in case of a master. Suppose assume that now if you say kubelet get pods, you could see that this pod is running, okay, because this file is there. Now assume that I'll move this file pod.yaml to the slash. I move this file. Now you see now no pod is there. Again now I'll move back this pod.yaml to here, back to the manifest directory. So I'm under the manifest directory. Now again you say kubectl get pods. See, again you get to create like this. You got it, sir? So the static pod, so whatever this path is there, right? etc Kubernetes manifest, whatever these YAML files are there, right? All these pods will get created. Here I created my own pod also. So this pod is not controlled by your API server. It is not scheduled by a scheduler. This pod got created by your kubelet itself. Even though if you remove it, kubectl delete pod and specify your pod name. Full pod you have to make this. See, again if you see, it got recreated. See, it will recreate again. Who is recreating here? Scheduling is not recreating there. It is created by your kubelet itself. Okay. Similarly, you see, I like that. See, same thing. If I open this pod.yaml, okay. So this is a pod. Now this is in the master. I don't have any worker node. Suppose I'll go to one worker node actually. Just for your example, I'm saying. I'll go to the worker node. Let me log into one worker node. Just for your knowledge purpose, I'm saying. So I'm into the worker one now. Okay. The worker one, I'll go to the same etc. What is it? Kubernetes manifest file. See, here I don't have anything. Okay. If I execute kubectl get, I cannot run here get pods because I'm into the worker one. You cannot run this command over here. Okay. Now what is happening is that actually, if you execute the command, if you create a file, something mypod.yaml, same thing I've created. Mypod.yaml. Now come over here, copy the same content. Here, go to the worker one, paste the same thing. I'm just showing it. Okay. Now you see that it has created it. How you'll get to know here? You come on to the master. You come back to the master here because you cannot run the kubectl get pod here. It will not work here. You know very well, right? Because you don't have a permission to do that. Because you are in the master, see kubectl get pods -o y. Here, will you make out, sir? In the worker one, it has created a mypod worker one. See?
Okay. Okay.
Clear? So as soon as you create this file under it, it will create it automatically. If you move this file, to the slash. Now we come back to here, master. See, you again need to get pod F1 override. See, it is gone. Then you move back from here, move that my pod to the present. That's you should be in manifest directory, sir. That's it. See. So now I could see that it is creating again. Okay. So static pod on the but these are the points, sir, which I told you. You have to tell in into the same way. Static pods are getting created. These are basically system pods. Static pods are always managed by the kubelet. Static pods are never managed by any master nodes. Scheduler is not aware of any of the static pods. And static pods are always created and managed by the kubelet agents running in each and every node. So let it be master or let it be worker node. In every node there is a kubelet agent running. And most of these static pods are always system pods actually. Clear, sir? So we have to know all these basic things. And if you go to the Google and if you just say static pods, you will get a lot of articles, but you have to go to the official document, see static pods. So what it says, static pods are directly managed by the kubelet daemon on a specific node without the API server observing. That's what I'm saying, right? Unlike pods that are managed by the control plane, for example, instead the kubelet watches each pod and restart if it fails actually. Static pods are always bound to one kubelet on a specific node. The kubelet automatically tries to create a mirror on the Kubernetes API. See, you have to read these articles. And one more way here, what is happening is that actually we are trying to create a static pod by setting into this path etc Kubernetes manifest, and here you are creating. Even you can do it in this way also, like etc kubelet.d under this directory also. If you sit and you create it, then also it will create a static pod. So there are two things: etc Kubernetes manifest as well as etc kubelet d also. Here also it is possible. This is the inside. So just go through this document, sir. This is a very good document about this kubelet. About this static pods. Okay, sir. So we have created. So today we completed these 4 topics, sir. Okay. So in the tomorrow's session, right? What we will do that we will try to cover RBAC and ropes and Kubernetes volume. Any one of these things, either Kubernetes volume or else config map secrets, RBAC, probes. These 3 things we can complete actually. And in the next week, Wednesday or Thursday, we will be covering this. Okay. And like in Saturday's class, right? What I'm planning, like in Saturday's class, I will be completing the HPC in 20 minutes. And in the remaining time, I will start with the Helm actually. So next Saturday, Sunday, I would be taking up the Helm actually. I'll make sure that in these 2 sessions, right, Saturday, Sunday, we will be completing Helm. And in 26th, that is a holiday, right, a Republic holiday, we will be covering a few of the things like troubleshooting or something. Yeah, one more thing, integration of Kubernetes with Jenkins will cover. This is very important, and some of them have asked that actually. In intro also they're asking these things. Have you integrated? Basically, when you are building a project, right, you need to know all these things. So that's what, sir. Hopefully, we'll see that actually by February 1st week we'll be completing many of the things. And from the February 2nd week, 12th, 13th, right, or else from the 10th or 9th, we will start Terraform, sir, actually. And what I will do now, sir, Terraform, how we will do means actually, with your this one, let me know, like if you are there in another 5 more minutes. So just what I'm trying to tell that for the Terraform, we will not do for the weekend, sir. Actually, we will do for the weekend. But what we will do, if you're agreeing, we will do alternate days, sir. Monday we'll start the class. Tuesday we will not be having. Wednesday we'll have the class. Thursday or else Tuesday we'll start the class. Like that we will do it. Because Terraform, I need 15 hours, sir. I have to complete the Terraform before 28th. I have to complete it, sir.
Yeah,
or
like Tuesday.
Yeah, Tuesday,
Yeah,
Thursday,
Thursday.
Friday, Saturday, Sunday. Yes. I need a minimum 5 hours I have to complete in 1 week, sir. If I complete 5 hours, in 2 weeks, if I complete 10 hours, another 1 more week, I can complete another 4-5 hours. 15 hours I need, sir. 15 hours or even less than that, sir. Some 10-12 hours I need.
Okay.
So that I will be able to complete Terraform by this. At least by February, first week, we should complete the Terraform. So once we complete Terraform, again we will start with the Ansible, sir. So that is my idea.
Okay.
And of course, as I discussed, I think, sorry, we can stop the recording.
Yeah, let me do.